Okay, so with that kind of definition of the bottom, the top, and the max and overflow, we can come back to talking about timer one and talk about um, this the second scenario. We already looked at a scenario where we had a microcontroller and a microcontroller pin, and let's say pin 1, and this pin was receiving an input. Let's talk about a situation where pin 1 is actually trying to give an output. So we are outputting here, and let's say for simplicity there is an LED connected here, and what we want to do is we want to give a high signal for a certain amount of time. So you know what this time is supposed to be, and you want to measure that time in the microcontroller and give it as an output so that the LED is on for that duration of time. So how are you going to do that? So one of the ways that you can do this is you can say, okay, here's what I'm going to do. I'm going to make this output 1, okay, and at the same time I'm going to set my count t count equal to 0, okay, and I'm going to let the counter run till the count, so my t count becomes equal to n. Okay, the reason why I'm using equal to is because I'm not setting t count as n, but I'm trying to compare. I want to see if my t counter is equal to n. If it is equal to n, which is like the number of counts that I need, so what I'm saying is I want to count from 0 to n, which is how many steps? It's n plus 1 steps, right? So I want to count n plus 1 steps. And if I get those n plus 1 steps, I'm going to make this input back to 0. Okay, so how much time would have elapsed? What the time elapsed would be n minus 1 times t timer, whatever that is. That would depend on the prescaler settings and the clock frequency. In different microcontrollers, it could be different. Okay,